I like this picture at the bottom because using big data for safety is still quite a young field. We still need to build this map towards successful use of big data. So I like to introduce myself as a cognitive psychologist who can write code, because I love both of these worlds. On the one hand, I am a cognitive psychologist, and I love human behavior and human factors, so all factors influencing human behavior and safety. But I also like data. I like numbers. I like seeing patterns in numbers and in data. But another route that we can also take is to make sure that the safer option is also the most attractive option. Now, unfortunately, this is often not possible. But we can try to make the safer option at least a bit more attractive. And we can do this by making sure that this safer option has as little to no negative impact on the other goals like productivity and innovation. And this is exactly where big data can help us. But of course, getting excited about using big data specifically for safety is only the first step. The second step is learning how do we actually use it effectively. Because there's usually already a lot of hype about using big data, but then we start with all this excitement and it turns out to be a bit disappointing in the end. So what do we need to do to prevent these disappointments? As mentioned, big data projects do not automatically succeed. Why? Why are some successful and why are others not? Well, of course, you can have some technical limitations. This is not my expertise. I'm a cognitive psychologist. So naturally, I focus on the human factors. So I think about which factors influence the human behavior, and more specifically, the human cognition of the researchers, the safety experts, and the data analysts. The quality of the operationalization is critical for the success of the big data project in safety. And operationalization is the process of turning an abstract concept, like the probability of a SPAD, in something you can actually measure, like the maximum deceleration to SPAD. And this is very difficult. And this can go wrong, and this can go wrong without anyone noticing. Now, I would call this project successful in terms of a big data project. Firstly, because in the final analysis, we could have this very firm conclusion for passenger trains. We could really say, with certainty, the safety level, or at least in terms of the probability of a SPAD, does not increase for passenger trains. And this is in contrast when you would only have, let's say, 0 SPADs. To compare with, well, before, in the same period, we also had 0 SPADs. Then you could not make a firm conclusion. But maybe even better about this project was what we did in the monitoring phase. Because we made sure before we started monitoring, so before the change in the infrastructure, we had very clear rules about what was sort of dangerous and when we would need to pull the plug. We knew what our criterion was for a near miss. We knew what the percentage was. If the near miss percentage went above, then we need to pull the plug, and we knew who we needed to call.